Good night, sir. Good evening, everybody.
Hey Tashana, how you doing? I was just waiting until 7. Oh, it's now 7. Hey guys, waiting. How are you?
I'm here, sir.
Nice. You know what? I was so ashamed of asking in the group. I'm sitting here for quite a number of hours trying to prepare a paper and trying to remember where on earth did I get to. Oh, thank you, Lord. Just remember. So you're looking at piecewise function. True or false?
Yes, sir. Yes, true, sir.
Right. So we don't start anything. The last thing we did was piecewise, right?
Yes, sir.
All right, good. All right.
And then we had a meeting that cut into that class time.
Great. Yes, you did. All right. So let me put something up on the screen as I do now while we wait on the other students to come up.
Yes, sir.
I would have done this before, but for the life of me, I just couldn't remember. I'm happy for how the meeting turned out, even though I knew from beforehand the outcome.
Me too, sir.
You knew the outcome before too?
No, the first part of it, sir. Happy how the meeting turned out.
I couldn't tell you the outcome before because I really wanted you guys to go to the meeting. Pains my heart to know that I missed the class, but I'm happy for how it turned out. I am one who fights for my students and my students' rights. And a few don't like that, but to hell with them. It means nothing to me. My students are the ones that. Oh, okay. So I can move into that. Okay, I'm moving into that. All right. Now I'm starting and finishing average rate of change tonight. We look at arts. I'm doing those 2 topics tonight. Matter of fact, I'm finishing this handle tonight, and hopefully in the 3rd hour I can start. In the 3rd hour I can start differentiation. Okay. All right. So let me just project something. Let me just write something here. Did I give? Oh yeah, I gave you those already. So let me just say example 4, example 5. I'm gonna be troublesome. Forgive me tonight. Forgive me tonight. Oh Lord.
Sir, good evening.
Hey, how you doing?
I'm not bad at all. When is your mid-semester, please?
I will tell you. Matter of fact, I'm sending off a mid-semester paper. I mean, the mid-semester paper is done, but I need to kind of get some juice into the system first before I start even thinking about that.
Okay, so it's not next week for sure. Thank you.
Bless up.
Sir.
Yes, please.
Good night, sir. I sent you some messages in the chat. I just asking you to look, please.
When you just sent them a while ago?
Yes, sir. Yes,
Okay.
sir.
All right. Cool. We'll look at it shortly.
Thank you, sir.
Right. I'm just trying to get a question in for you guys. Equals to 1. X is greater than or equals to 1. All right, I'm coming up now with it. All right, so that one works.
Sir,
Yes, please.
your microphone is very low.
Oh, it's all right. I know what it is.
Okay.
Better now?
Yes, sir.
Great. I was listening to something earlier and it was oh, don't do that. All right. All right, so okay, so now I am gonna share the screen. This is just example 5 as I do know. Okay, warm up class.
Okay, sir. So this one, example 5, that's the one we need to work on now?
Yes, thanks.
All right.
So I give you a couple to do that for me.
My love for you. Anyone finish, Anika? Priscilla, your microphone is open.
Okay, sir,
I'm hearing you. Go
I
ahead.
believe I finished doing. I believe I finished doing this warm-up exercise.
Okay.
All right. Do I take a picture and send it in the chat or do I explain it?
No, let me hear what you're saying. Talk to me. Talk so the others can also hear.
All right. So this piecewise function. So we're to determine if P of X is continuous. My answer is no, it's not continuous. It is, what's the word? Discontinuous. That's the word you use.
Mhm.
From the left-hand side, where you have, where X is equal to 1, that
Mhm.
piecewise function where you have X is less than or equal to 1, was it not 1? Starting in the middle, you say X. So X would be less than 2, but it is greater than or equal to 1. That's the middle one. That's 5x minus 3. That's the function. So in the function, I'd replace the 1. So it would be 5 times 1 minus 3. The answer would be 2. And the second one that's coming from the right-hand side, where you'd say x is equal to 2, where you have in the function x is greater than or equal to 2, I'd put the 2 where the x is in that function. So it's 2 times 2, that's 2 2's, plus 3 is equal to 7. So on the left-hand side, you have 2. On the right-hand side, you have 7. The two numbers don't match. So it's not, it's discontinuous.
Okay. I need to look back at something because I need to look back at something here. What is the middle function?
The middle function is it's 5x minus 3.
So how you get 7?
All right, so where x is equal to 2. No, I didn't do that way. No, sir. That one where I have 5x minus 3 is where 1 is less than x. 1 is less than or equal to x.
I
So
hear you,
since this
but you
x is
said
equal to 1, I use a middle function for the left-hand side.
I hear
I
you.
got 2
Right, but I
for the
hear you.
function 5x minus 3. I got
But
2.
you said something about 7. How does 7 come in? How did we
Right.
get
So
7?
this the other one now where you say x is equal to 2 using that function 2x plus 3, where x is in that function, I put in 2 because x is equal to 2. So 2 times 2, which is 4, plus 3 is equal to 7. That's how I got 7, sir.
Okay, all right. All right. I hear you. Anybody else?
So I see everything we're doing us if that's wrong too.
So the answer that Tashana got is the same answer that you got?
Yes. 217.
Okay, so what's the statement then?
But it is not.
It's not what?
It's not what continues.
It's not continuous. At what point though? There are 2 points. There are 2 points. So which points are you talking about? It's not continuous where? It's not continuous at x equal 1, not continuous at x equals 2. Where is it not continuous?
So I think you may have to explain that part back to me again. I'm not sure.
Tashana, where is it not continuous?
On the left-hand side, I got 2, and on the right-hand side, I got 7. If
So
both of
therefore, what
them
is
were
the
the
statement?
same number, it would be continuous.
Good. So what's the
But both of
statement?
them it's discontinuous, bad behavior, sir.
Okay. All right. Okay. All right. What about the others? I need to hear from the others. What
Sir,
about
good
the others?
evening. Sir,
Yes.
good evening.
Yes, ma'am.
Good evening, sir.
Hey, Mom, what's up?
Everything up, sir. I am done. Sir,
Hey.
I don't get a good understanding of this yet.
Okay. That's why I tell me the good evening in such a let me at war. Good evening, sir.
No, sir, it's not
Yes,
you.
man. I'm me, man. I'm me.
Sir,
Me I wonder.
I'm
Me I
not
wonder. Me I wonder when me do Maria tell me good evening, so strong.
sir.
You tell me good evening very strong a while ago.
Sir,
All right, never mind.
you know, but sir, I am a bit distracted where I am at evening times in the class, sir. I can't hear, and I'm not getting it, sir.
Yeah, I hear the frustration in the voice. All right, let's go.
Yes.
Let's go. Let's go. No, before I go, man, 17, 16 out one of the. I want to hear from Shackleford, I hear from Marie, and I hear from Tashana. What about the rest of you? There are 14 more of you, 13 more of you. I need to hear something from.
I use the top function instead of the 2x plus 3.
Okay.
The x squared minus 1 all over x minus 1. That's the function I use, and I got 0.
You got 0.
But I got the second one, which is 5x minus 3. I got 2.
You got 2.
But
where she got 7, you got 2.
Oh, sorry,
Yes.
same one, that 5x minus 3.
I use the
I got 2 for that
5x minus, yes, that's
Okay.
that's the middle
Okay.
function I use,
Yeah.
but I use 2x squared, not the 2x squared minus 1.
X squared minus 1. Fair enough. Got you. What about the others? Thank you, JD. What about the others? I need to hear from you guys. Tammy, you are not allowed to come to my class and not speak to me. I'm very sorry. I take it personal. Miss Vogel, I need to hear from you. Vanessa, if you ever met a scrape with your dinner tonight to see, you're bored, so you're hungry. I need to hear from you. Romaine Query, I need to hear
Sir,
from you.
I didn't grasp this concept properly, so I am kind of somewhat lost.
Vogel.
Yes, sir.
We're not on speaking terms tonight, you hear?
I know, sir.
Okay, thank you, please. Emilio, Priscilla, Rashid.
So I'm still trying to work it, so just give me some time.
Okay, then.
Yes, Sir Sean.
No, we're not on speaking terms, you know. No, we're not on speaking terms. I scrape out your food and inhale it already.
That's along the way.
All right, then, never mind. I hear you. And you see, that's why I sorry give the question, you know. If you think I couldn't start when I had those 4 students, I said, no, let me drop the question because I know exactly what is happening. All right. Where is... All right, let's go. All right, so I am hearing and I'm listening to the conversations. And remember, guys, it's important. None of you should be nervous or reserved to speak to me because I'm not one who bites. I'm one who listens, and I'm one who tries to get where it is that you're at and to use what it is that you have in order to get to the point where I want you to get. It's very important. And so important that you must understand this because this is on your mid-semester exam. So let's go. So it says, warm up. Determine if P of X is continuous at X equals 1 and X equals 2, given that P of X is equal to that piecewise function. All right? So we now need to look at, we need to investigate what is happening at X equal 1 because it's piecewise, as it says, piecewise. We have to do it piece by piece. We can't do it one shot. You know, I can eat a cow, but I can eat the cow in pieces. All right? So let us see how we are going to be doing this question. Forgive me, I'm just being lazy by trying to go through the stuff here. So X equals, so we're investigating what happens at X equals 1. Now, Marie and the rest of you, I want you to listen because Sir is moving on tonight, you know. Because if Sir stays here any longer, we're not going to finish the syllabus and I am finishing off. All right, so hear me out. So I'm looking at X equals 1. I'm looking at X equals 1. Sir, why are you looking at X equals 1? Because the question says, determine if P of X is continuous at X equals 1 and X equals 2, given the piecewise function. So the question is asking me whether or not the function is continuous at x equals 1. But I have to do the question piecewise. Means say, I have to do the question piece by piece. I can't do it in one whole chunk, bite sizes. So I'm first investigating what happens at x equals 1. Then sorry, I have to do x equals 1. If you want to do x equals 12 for your business. But I like to do things in order. So because x equals 1 comes first, I'm going to do x equals 1. All right, let's go. So because I'm looking at x equals 1, I must investigate to the left of x equals 1 and to the right of x equals 1. I must investigate to the left and the right of x equals 1. So what function is to the left of x equals 1? Tell me, what function is to the left of x equals 1? And that's a question. Don't all rush me at once.
Sir?
Sir, correct me if I'm wrong. Just say that from now. I use the first function.
Me don't know which is first. Tell me name it.
X squared minus 1 over x minus 1.
JD, why did you use that function?
Sir, I can't explain it. We just
You have to explain it. You can't just pick one. You have 3 functions and you decide to take up that one day.
Because that is that the left of x equal 1.
Oh, you know that, Marie?
Because, sir, in front of that function, I see x equal 1.
You see what?
X great.
X less than and equal to 1.
You know, so no equal sign there.
No, equal to there.
X
Just
less than.
Oh,
less, sir.
You see what?
Less than.
Oh, when it less than is what?
If it's less than 1, it's supposed to be 0 or 1.
If I clap on it tonight to say man on the puke. If it is less than what it said, I told you something very good. You remember I tell you left, L and L. So if it is less than, it is to the
left.
Very good. So JB, you are correct. So it is less than 1. The condition says, so you don't just tell me, so let me use the first one. That will make it. You have to look at the condition. The condition says x is less than 1. So since x is less than 1, when it is less than, it is to the left. Guys, I gave you this in the notes. We don't know what else to do, you know. But come on to this in the notes. See, please note, to the left means less than. This is the last time you're going to see this because I ain't going over this again after tonight. You have to reinforce what is done. Less than means to the left. So therefore, greater than has to mean to the right. Then, sir, what if you had less than or equals to? It no matter. It is still to the left. Okay, sir. So that means if you have greater than or equal to, it still is to the right? Absolutely. Uno hedge that into uno as a matter of fact. Repeat after me. To the left means, hold up. Repeat after me. To the left means less than.
To the left means less than.
To the right means greater than.
To the right means greater than.
Say 2 more times, so please.
To the left means lesser than. To the right means greater than.
1 more time.
To the left means less than. To the right means greater than.
And for those of you who did not open your mouth to say it, you will have a difficulty passing the course.
You know, sir, it was there and I never click, and that's why I end up, you see, them something there, make a lose marks.
Which
just
is the point.
because it says equal to, because I was doing the algebraic thing, that is where I went wrong. The piecewise function requires us to apply the, what you call it again?
The intuitive approach.
Intuitive approach, where you go below it and you go above it.
And you heard me say that before, right?
Yeah, it just never clicked, sir.
I am saying to you, students, when sir sits behind it, remember, no, hold up, let me just tell you something. Honestly, I'm glad for the online exam, and as a result of it, the online classes. There is, it's just like how I can write an exam question. I said, show that f of xy is equals to f of yx, or you're going to show me when you're doing an online exam. So I have to know how to write the online questions. So when I'm writing a question for your online modality in your final exam, I can't write the paper as if you're doing a face-to-face paper. So I have to use some levels of jargon because it is an online exam. So I can't put indicate on the graph, right? I could ask you to whatever it is, to mark the axes using the coordinate or state the coordinate from the graph, because you indicating on the graph, you can't do that to show me because it's an online exam. So I would rather say to you, state the coordinate for which whatever it is the question is. So when you're writing an online exam, it requires the use of terminologies that I cannot do for your regular face-to-face paper. I say this to say to you that learning cannot be in the same modality as if we were doing face-to-face teaching. No. So when sir comes to class and when sir speaks and when sir reinforces some stuff, you see, I put it in the handout that I gave you, please note, because what it is that I'm doing, I'm trying to highlight those specific areas that will make the understanding a little clearer. You have to pay attention to it. I also said to you, when you're doing your piecewise function, it is so identical to you doing the intuitive approach, because you have to investigate what happens to the left of the function as well as what happens to the right of the function. Now, hear me out.
Sir, sorry. Oh, you sound so low.
I am low. I don't know.
Yeah.
I'm low.
Yeah.
You're very low.
Sir.
Yeah.
Sir, low.
I have
ask if you're low.
Am I low, guys? Are you hearing me?
Not right now. I can hear you now.
No, sir. You're quite all right to me. For me.
JJ, check your volume, JJ. I have nowhere else to go. I'm at my max. All right. So, guys, hear me out. This is it. This has to be it. The understanding must be achieved tonight.
All right. So, sir, I have a question.
Go ahead.
If this first function that refers to the one that goes to the left-hand side, which is the first one, in this instance, x would be equal to 1.
Thank you. Yes.
In working it out.
Yeah, man. X has to be equal to 1. Remember, for the intuitive approach, we know that the function only approaches, but we're going to be assuming that it's going to be equals to. Remember I said all of that when we're doing the something?
Yes.
Yeah, man.
Yes, sir.
Come on, man. I can't do this to teacher in the Tuesday night, man. Teacher come
so, sir,
ready for class.
When we get the 0, sorry, when we get the 0 right there, so we're not supposed to try to work that out any further for this one.
Stop. When you get 0 over 0, what is it?
It is
undetermined.
Indeterminate.
Indeterminate. That be right, sir. Actually, I'm not.
And when it is indeterminate, JD, what do you do?
You do one next something, but me not remember.
JD, if I take off the people them here off of your head, they say JD, you cry.
Sir, so violent.
No man, I JD, so I can't trouble. It's only me I know supposed to trouble JD. You see,
so when I get indeterminate, you have to wait him there. Either the function, try to find the function, but they wait him in the function.
Right. What is causing the function from the thing to come out? Yeah, man. Right. Yes. Hey, JD, when JD had trouble me, in my class, no, sitting and said, JD, leave my nice teacher alone, right? But when me had trouble JD, you're going to say, sir, DJ, no. When JD had trouble me. But anyway, the point is, JD, yes. So at some point in time, now, JD, you must make a notation in your book to say when it is indeterminate, it's one of three things: factorization, simplification, rationalization. I must do one of three small little things in order to, the same thing what Emilia just said a while ago, to take out something that is preventing something from coming out. All right? So when you substitute x equals 1 into this function, and I was just being troublesome when I wrote this question a while ago out of my head. When you do this question and you put 1, 1 squared is 1 and 1 minus 1 is 0. And 1 minus 1 is 0. So you have the indeterminate form. So because it's no indeterminate, there is something that must be done in order to get out what it is that is causing that problem. What is it, sir? We don't know yet. Let's see if we can find out. So what do you recognize with x squared plus 1? What do you recognize x squared plus 1 to be? Oh, Jesus. What do you recognize x squared?
In the function x squared
plus 1. What is x squared plus 1? What do you recognize x squared plus 1 to be?
Is it plus or minus 1 that was there, sir? All right, so if
x
is 1 and this 1 squared would be 1.
That's not what I'm asking. That's not what I'm asking. Give me the name of x squared minus 1. X squared minus 1 has a special name. What name does it have? What name is that special name? What is it?
A function, sir.
JD, where's a while ago?
Power? That?
No, man. Something else, man. Think about it. Something else.
The C word, no, never mind.
So, Mr. On a function, sir? Oh, all right.
I know what the problem is. Your algebraic skills, guys, are weak, and that's the problem. It is called the difference of two squares.
I hope we forget it, no, sir. All right, so sir, I'm looking at what you have on the screen. Is it that we have to apply the same thing that we had when we determine the highest degree, then those are equal to 0? That's the same process you're using here, sir?
Yeah, you have to factorize things. Remember, I told you remember JD just said while ago and said, sir, write down indeterminate, you know. Yeah, but it can't just write down indeterminate.
I have indeterminate, 0 over 0, indeterminate.
Yeah, but it cannot end there. That's the point I'm making. It does not end there. So there, because it's indeterminate, you hear what Emilia says? Sir, because it's indeterminate, there is something in the function preventing the true limit of the function from coming out. So we now need to go and find what is preventing the true limit of the function to come out. So we have to do either a factorization, a simplification, or a rationalization. Looking at the function, x squared minus 1, you recognize that that function can be factorized. That function is known as a difference of two squares. That function is known as the difference of two squares. The difference of two squares. How do I write this now, Lord Jesus? The difference of two squares. I'm trying to put something.
So same like how you say it, the same way you write it, man.
Yeah, man, the FFERENC difference of 2SQERES. No, man, I'm trying to do something here so I can even send you guys some notes because it now work out. On a now study. And it is going to come back to bite you, and then after that, no, fail the course, and I say, sir, the semester was too short. I have.
Sir, sir, I know say we now study, you know, history is a whole heap of information for getting for the amount of courses where we do, plus to concentrate on your work and all other personal things. So I whole heap.
On a now study. I mean, not take it.
Yes, we are look over, sir. We are look over.
All right, I can tell you what is happening.
What is happening?
I can tell you what's happening, sir. I spent hours sitting down on one question on Edgar stuff because for the life of me, I'm trying to remember what I learned. If not, I forgot to search for the book where I learned from first semester how to work out that problem. A simple process of doing division where it comes to rational numbers, rational functions, right? Doing division, and I am lost. It's lost on me, and I know I learned it. I know I did it, but I just don't remember it. So I sat there looking at it, trying to figure out how them get that number, and that's where I'm stuck. So I would like to move on from that, and I think I might very well have to go over it and go to something else because time is of the essence. But that is what is happening. We spend too much time away from math in the last semester and the semester before that, and most of what we had absorbed and learned, it's kind of vague. I'm being very honest. I'm speaking for myself.
Point taken. And I it's just a pity that none of you reached out to me to say, sir, why am I not doing a math course? I never knew until we got to this class. But nonetheless, you said it just now, Tashana. The deficiency is the algebra. You've done this stuff, but you're just not remembering it. But anyway, let's move. So I am putting this notation here as a difference of two squares. The difference of two squares, so that when you look back at it, you will always remember how it is that sir got it. I'm factorizing. It's a factorization. And because I recognize x squared minus 1 is a trinomial, but it's a special trinomial where the value of b is equal to 0. So instead of having ax squared plus bx plus c, I now have x squared plus a negative c. And that's why I have my x squared minus 1. And the x squared minus 1, as I told you, for those of you who are taught Foundation Concept 1, I told you that when you have two terms, the first term is a perfect squares, the last term is a perfect squares, and it is separated by a negative sign, it is known as a difference of two squares. The first term is a perfect squared, x squared. So how x squared is a perfect squared? Because x multiplied by x is x squared. So it's the same two things that I multiply together to give me something saying that is a perfect squared. Then sir, how 1 is a perfect squared? Because 1 times 1 is 1. So it is a perfect squared. Oh, so that's what it means, sir. By the first term being a perfect squares, the last term being a perfect squares. Oh yes, sir, see it now. And the middle sign, sir, the sign that separates the first and the last term is a negative sign. Okay, sir, that's what the difference of two squares is. So having now written the difference of two squares, I recognize that something in the denominator of the x minus 1 goes. So all I'm left with now is the x plus 1, which is here. So now it is that I can substitute my 1. You notice, JD, you no longer get the indeterminate form because when you substitute 1, you're going to end up with 2. So you know that the limit of the function x squared plus...
Yes, sorry, the first term is a perfect square. The last square is a perfect square.
The last term.
The last term
is a perfect
square.
Separated
and
by
the sign that is separate the two of them is a negative.
Absolutely. And that's what is the difference of two squares. Absolutely. All right. So let's go. So now, remember, sir says, when we're looking at the intuitive approach, I must look to the left and to the right or to something. You buy one house, and JD can't tell enough things about that. We are back. So remember, JD, you buy one house, you can't just look on the house and say, yeah, the house look good from the front. No, you have to walk around the house and look to the side and look to the other side and look to the back. If the back of the house in a one gully, me not buy it. Because when the gully water comes, it will swallow my house. So you have to look, you have to investigate, guys. You must investigate. You can't just take it at surface. You have to investigate. So I'm investigating what happens to the left. I'm also investigating what happens to the right. So having looked at the left, up top here, I now need to look at what is happening to the right. Which of the functions, see here, x tends to 1 to the left, x is now tending to 1 to the right. Which of the functions in the piecewise function deals with 1 going to the right?
Sir, the third one.
Father, forgive JD. Father, should normally but forgive our Jesus.
Sir, now the middle one with the 5x minus 3. The one there.
Why, Marie?
1 equals to 1 less. Are equal to 1. 1 is less than.
You read it inside. You read it inside out, Marie. You read it inside out. X is greater than or equals to 1. X is greater than or equals to 1. So you're reading the double inequality always inside out. So x is greater than or equals to 1. No. Remember, you're looking at the function that deals with 1. So you're not looking at the x less than 2, because x less than 2 is a different limit that you're looking at. X less than 2 is the limit of the function tending to 2. So you're looking at the function that tends to 1. So it says no, x is greater than or equals to 1. So greater than or equals to is to the right. So the function to the right then, JD, is going to be 5x minus 3. 5x. 5x minus 3. Right? No.
That is also equal to 2, so it is continuous, sir.
Which is why I was asking you the question based on,
yeah.
It's because I just wrote the question a while ago. I know what it is, how I wrote the question. I know what answer I was looking for, which is the point I'm making. So when you said that to me, I said, okay, fine, let me not even kill it. So yes, so it is going to be equal to 2. So what is your statement now? Since the limit
Sir.
Yes, please.
Sir.
Yes, ma'am. Go ahead, Marie.
Don't confuse anybody, but just want to appear understanding. That means, sir, the 5x minus 3, that is a function by itself, right, sir?
Absolutely.
And then the lesser than 2 is a function by itself.
Absolutely. There are 3 different functions in the piecewise function.
Yeah, sir, it's like me did out of it, you know, so me never get what you were saying last week. So I'm just trying to understand.
Yeah, man, and that's fine, Marie. You notice I'm not. You are talking to me strong, you know. Me not talking to you strong. Me understanding. So go and get the understanding, man. So yes. So remember now, when you look at the piece, let me see if I can carry it up a little bit more so you can see the full function. So when you look at your piecewise function, your p of x. The question says, determine if p of x is continuous at x equals 1 and x equals 2. And they gave you what p of x is defined by. They gave you what p of x is defined by. Now, the mere fact ain't no hard, you know. Let me tell you, I'm going to tell you how. Well, I have been telling you. You have 2 numbers. You have 1 and 2. You have 1 and 2. So you need to investigate what happened on 1 to the left and right of 1, and you will investigate what happened to the left and right of 2.
Left and right of 2. That's where I went wrong.
And then now, when you said to yourself, no, because since okay, so they said to you, determine if p of x is continuous at x equals 5 and x equals 6. 1, you have to look to the left and right of 5 and to the left and right of 6. All right? What you know, when you write down something to say to the left and right of 5 and to the left and right of 6, you have to say to yourself, which function led to the left of 5 now? Which function led to the right of 5? Which function led to the left of 6? Which function led to the right of 6? That's all you're doing. So when you look on the function, you say no, I say x equal 1, x equal 2. All right, sir. We have to go look to the left of 1, the left of 2. Check. Then we have to look to the right of 2, and to the left of 2, and to the right of 2. Check. The next question now, sir, what is to the left of 1? Go into the piecewise function up here, so, and look to see what is to the left. Left is less than, right is greater than. So which function in the piecewise function is speaking about x is less than 1? Because if x is less than 1 or less than or equals 1, because it could be one of the two, but it's a less than function you're looking at. And the less than function with respect to 1, because it's 1 investigating. And it is only the first function, x squared minus 1 over that. There's no other function in the piecewise that deals with x being less than 1. The other function with 1 is x is greater than or equals to 1. So you're going to write that one there down, x squared minus 1, then you're going to work with it. And when you work it, you're going to say, boy, you're going to get indeterminate, 0 over 0. And when you get the 0 over 0, then you know, say, boy, you know, you have to go to 1 or 3 little small something, you know, a factorization, a simplification, or a rationalization, because something, you know, there's something that prevent the true function from coming out. When you clearly look at the function, now you recognize that the function is the difference of 2 squares. You can factorize it. And when you factorize x squared minus 1, you will get x plus 1 times x minus 1. Aha! The x minus 1 in the denominator, sir, will now cancel with the x minus 1 in the numerator. So I'm only left with x plus 1. Now it is that I'm going to go and substitute the value of x into that function. And if x is equal to 1, as is given in the question, it's going to be 1 plus 1, it's going to be equal to 2. So therefore, sir, the limit of that function, the true limit of the function, occurs when x equals 2. Very good. Let us continue with the investigation. Having completed what is happening to the left of 1, we now need to look at what is happening to the right of 1. We now need to go back into the piecewise function to see which function deals with to the right. Guess what? There's only one other function in there that deals with to the right. It can't be the last function, 2x plus 3, because the condition to 2x plus 3 said x is greater than or equal to 2. So it may have to go back to the middle function, which is going to be 5x minus 3. So the limit as x tends to the right of 1. See there? Remember, we read inside out, you know. So the 1 less than or equal to x less than or equal to 2 is not read that way. It is read. Let me see if I can spotlight this thing about here. Okay. Annotate. Annotate, annotate, annotate. What here? All right. Right. So hold on. So what is? All right. You see where the spotlight is?
Yes, sir.
Yes, sir.
Good. So write this up. Write this up. You have to look at it because how that inequality is read, I gave you that into a handout this is the 4th week, some 3 weeks ago, right? And it says x is greater than or equal to 1, but less than 2. X is greater than or equals to 1, but less. Oh, but sir, greater than means to the right. That means that the function is 5x minus 3. That's why I use the 5x minus 3, sir. And then now we're going to assume that x is going to be equal to 1 as per the given question, x equals 1, right? And then 5 times 1 is 5 minus 3 is going to be equal to 2. Sir, we catch that one there now. So, sir, what we now need to do is to investigate what is happening at x equals 2. We now need to investigate what is happening at x equals 2. I agree. So let us see if we can go and investigate what happens at x equals 2. Now, at x equals 2, I need to look to the right and left of 2. So let me go and fix this. So without even looking at the piecewise function, I know I'm supposed to look to the left and right of 2. See the thing right there, so? Thing right there, so? I must look to the left and right of 2 because I'm investigating what is happening at 2. Now that I write down the x tends to 2 to the left and 2 to the right, meaning if I catch up in the question, in the piecewise function now, to see what is to the left of 2. To the left of 2, it says x is less than 2. So x being less than 2, it means that this function 5x minus 3 is to the left of 2. So I'm going to come back down here, and I'm going to put 5x minus 3. And that's what we got our 7. No, to the right of 2. Definitely no. Has to be, because that's the only something we left. Has to be no. The 2x plus 3. See there? X is greater than or equals to 2. Greater than is to the right. So it's going to be 2x plus 3. It's going to be 2x plus 3. And you're going to substitute the value of 2 into the function. 2 times 2 is 4. 4 plus 3 are 7 or 2?
Yes, sir.
This is the height of greatness, you know, because guess what? Me never wanted to be continuous, you know. We want to be discontinuous, but anyhow, it works out safe continuous. All right. Okay. So both of them, the function is continuous both places. My question to you now is this here any clearer to you than it was the last time we met?
Yes, sir. I get it now.
All right. Is there anyone in the class that is still
Much clearer, sir.
good? Is there anyone in the class that is still fuzzy? Is there anything that you want me to just talk about that you're not too clear about because sir wants to move on?
A little clearer to me, sir.
Say it again, honey.
Saying it's a little clearer, kind of get a better understanding of it now, sir.
Very good, very good. All right. So you know what I'm going to do then? I have to move. I'm just going to ask the question once more. It's now 8 o'clock. I'm going to ask the question once more. And then what I'm going to be doing is I'm going to see if I can just be mischievous like I did at the start of today's class and just wrote a question. And when I wrote the question, I'm going to see if I can be mischievous and write another question. Write another question so that I can give to you to go and work, students. Let me just stop and say something else. Story time. You stand a better chance when you pass the mid-semester, because I can tell you what to prepare for the mid-semester. For the final exam, I can't tell you what to prepare for because I don't know. It is easier when you go and you do your mid-semester, you get a 70, 80, 90, 100 for the mid-semester. And you get up there and you finish up your work and editor stuff and you go into the exam with 32, 33, 34, 35, 40 out of 40. And if you follow up on your first groups, at least you can still come out with a little C instead of having to do for the course. We now say must work for C. But if you fall down, at least you still can pass. Some people fall down in the exam and can't recover. They need them creep up, them can't walk after. And if we get some rest and then come back under the course again, you don't have time for that. Why am I saying this to you? That topic head up on your mid-semester paper. You have to learn it. There's no two ways about it. It depends on it. You have to learn it. Okay, so with that said, I will do, I'm not going to give any other question in class tonight because I must move on. Guys, you have to work with me now because if I don't move on, only same man will complain and say, boy, sir, come to class and sir, they are moved too slow, so we can't finish the syllabus. All right, so I gave you your warm-up. Let us just look at some continuity. And those 3 conditions are the conditions for, matter of fact, at least I was going to ask the question again. Is there anyone in the class that still has an issue with the piecewise functions that I have just completed?
Yes, yes, sir.
What issue do you have? What issue do you have?
I'm gonna forget see about the question again to see which part. All right, so that so which one later? In terms of the fx minus 3, you said that was the one that is to the left, which is less than 2.
I don't have an fx minus 3. 5x minus 3.
5x, that's about fx, sorry, sir.
5x minus 3 has 2 conditions. To the left of 1 and to the right of 1, I'm sorry, and to the left of 2. Okay, to the right of 1 and to the left of 2, yeah.
Okay, we're dealing with the 2, so that's why I get f of x minus 3. 5x minus 3, so that's f of x. Okay. All right. I think I get it a little bit more now, sir. If not, I'll do some more practice on my own and come back to you.
I have no problem with that.
All right, sir.
Blessings. All right. Now, one of the things that I want you all to learn of, sir, is that I know when students are learning and when students not learning, and don't expect me to sit down and call in individually to find out if it is that you're learning is something is so messed up. And so me I say to you, say if you not understand, if you let me know, I mean I am moving on.
Sir, good night.
Good night.
And this is Joan. I don't catch everything, but I'm gonna get somebody at work to go through with me.
Okay, Joe. All right. And if when that happens and you still don't catch it,
yeah,
come back to me.
Okay, sir.
All right. All right, let's go. So where we are now is continuity, and those are three conditions for continuity. The statement of conditions for continuity is that f of x exists. F of x exists.
Oh, you have it spelled wrong, sir.
Huh?
You have the exist spelled wrong.
Yeah, it says exit, don't.
Yeah.
I may just see it a while ago.
So you're going to send that paper, the one that you just did?
I normally do.
Yes, sir?
You know what I normally do? You never get the last one, last class?
Yes, sir.
I normally do. Yes, thanks, Amelia. I see it says exist. Oh, Jesus, it says exit, right.
To your maths genius, the English does well with me, you know?
Well, actually, on the contrary, I think I have a mastery of it also. But yes, yeah. But it's supposed to be exists, yeah. So f of x exists. And what happens is if f of x, sorry, that's not what happens. Sorry, I've just got a blank moment a while ago. So what it is that we're looking at, look at B. Is B the same thing that we just did a while ago? Look at the limit as x tends to the right of a of f of x is equal to x tends to the left of a f of x. That's what we just looked at a while ago?
Basically,
yes, sir. Yes,
It's not basically, it is exactly what it is that we looked at. So what I'm saying to you here is that f of a exists. If f of a exists, then you're going to look to the left of the limit. You're going to look to the right of the limit. If to the left of the limit equals to the right of the limit, then you're going to say no, the limit as x tends to a of f of x exists. The limit as of, see here, the last piece said this, other piece here said no. Once to the right and to the left occur, then you're going to say the limit exists. Sir, I don't know what you're talking about here, sir, because them something just confused me. I just see him something we just do a while ago. See it right up there, so. See it, so. The limit of this to the left equals to the right, then the limit exists at x equals 1. See that? Continuous at x equals 1. So we're saying that the limit exists. You see that?
Yes,
and
sir.
that's why you need to write that statement. Because you see, a lot of times some teachers will just give you these three things to study. I don't let you study them three things. I give it to you to write as your statement.
So
when
sir,
you're
question. So it is continuous at 1, it is also continuous at 2, because 2 I think equals to 7 on both sides.
It's continuous both places. So the point I'm making there now, I'm just showing you the conditions for continuity. So I'm saying, I'm just showing you that that's exactly what it is that we've done. In the question, that we did just now, the limit as x tends to 2 to the left of 5x minus 3 is going to be equal to the limit as x tends to 2 to the right of 2x plus 3. Sir, or you know to them equal because the two of them equal 7. They're of a good behavior. That's what we mean. When the limit exists, we see them behaving well. So that then, sitting around me tonight, you know. That's supposed to be then, you know. Oh, Jesus, THEN. Then P of x is continuous at x equals 2. Then P of x is continuous at x equals 2. See it yourself? Then the limit as x tends to a of f of x exists. And then the last statement is the first one up here, so f of a exists. See it yourself? F of a. And see the middle piece here now when we say the limit as x tends to a of f of x, see here? The limit of x tends to a of f of x. So you must say to you're checking to see if f of a exists. What is f of a, sir? Come here talk about f of a. I mean, I don't know where a comes from. A is the limit of the function. So you substitute the limit of the function into the function itself. Remember, you know, as I said to you, you know, that the function is not equals to, the value of x is not equal to that, the x value. But we know that the limit is approaching x. But for the calculations approach, we are going to substitute the value into the function. So we are going to say f of a exists. Sir, what is a again? A is a function, is a limit of the function. Like x tends to 2, 1, x tends to 3. If you're going to substitute another function into f of x. So anywhere in f of x you see x, you put a. That's what it is saying. So f of a exists. Anywhere in f of x you see x, you put a. So you're calculating f of a. So having calculated f of a, then now f of a is going to exist, you know. If when you look at the limit of as the function tends to a to the right, and the limit as the function tends to a to the left, if the two of them something they're equal, then you say that the limit is of a good behavior, and that f of x as the limit tends to a exists. And then the third condition now is just you putting the two of them together to say, boy, them equal, you know. F of a is going to be equal to the limit as x tends to a of f of x. And you're good to go. Those are the three conditions. I've gone through the three conditions. Let me tell you what they love to do in the exam. In the exam, they love to say, state the three conditions for continuity. See them here? You all have it. I've explained to you what the conditions are. So nobody don't say, sir, never talk about the conditions for continuity. These are the three conditions for continuity. F of a exists. The limit as x tends to a to the left, as x tends to a to the right. If the two of them equal, then you're going to say that the limit as x tends to a of f of x, and then you put in both of them together. F of a is going to be equal to the limit as x tends to a of f of x. All right? That's what it is. So we're going to look at some examples. We're going to look at some examples. Let's just look at the first example here. I'm going to explain the first one. Oh dear, I didn't do it. I only had time to just, I wonder if I did copy the rest of them because, right, I did. All right, so I did 5 of those for you. So tonight is going to be, tonight is not a night where I'm going to talk. I'm going to do the first example and give you about 10 minutes to work on the other examples for me, and then we'll come back and have a conversation about them. All right, let's go. Example number 1. It says find the values of x for which f of x is discontinuous. And you know, and another word for discontinuous is undefined. So I'm asking you to find the values, you notice I'm saying values. I'm saying find the values of x for which the function is undefined. So I'm telling you that there are 2 values, or 2 or more values, because it says values, right? So you know it's not one it has. Now, a function is undefined when you have a 0 existing in the denominator. As I told you over and over and over and over again, sound like a broken record. I've told you so many stories. So let me just repeat this story. A function is undefined or discontinuous when the denominator is equal to 0. You
Sorry, I
can't
go
build.
too fast.
A function is undefined when the denominator is equal to 0. Function is undefined when the denominator is equal to 0. A function is undefined.
Sorry, you did write that somewhere on the paper somewhere?
I didn't write it, but we say enough time. All right? But I'm going to write it now, though, because I never did the solutions for this. I'm going to write it now.
Okay.
So the function is undefined or discontinuous when the denominator is equal to 0. So you want to find out now the values of x, because the question said the values. So you want to find out the values of x when the denominator equals to 0. So all you're going to do is just set the denominator equals to 0 and just work it. And whatever answer you get for x, you fling that down and give them and say, are them two values x here cause this function to be discontinuous? Sometimes the question say discontinuous, sometimes the question will say undefined. Synonymous. All right? So let's go. Let's go. So let's go. So the Jesus, what is wrong with Jesus? Oh, simple. If u n. So the function is undefined when the denominator is equal to 0. Every time. Every single time. All right? Now, so therefore, what I'm going to do is I'm going to set my denominator here to be equal to 0. So I'm going to set this equal to 0. I'm setting that equal to 0. Sir, why? Because the function is undefined or discontinuous when the denominator is equal to 0 every single time. So I'm going to be factorizing. So therefore, that is equal to 0. So we factorize. So to obtain the value or values. All right? So we're going to factorize to obtain the value or values. I'm going to multiply the coefficient of x squared by the constant. So 1 times 20 is 20. I need two numbers. When multiplied together will give me 20, but when added will give me 9. Or two numbers.
4 and 5. 4 and 5.
4.
Very good. That's exactly who I want to hear my class. Looking at the something and just telling me what them something there is. So we're going to say either copy. Let's be lazy tonight. Either x plus 4 is going to be equals to 0, or x plus 5 equals to 0. This implies that x is equals to -4, x equals -4, or x equals -5. All right, so that's what that is. And this exercise is one that will help you with your factorization. So, oopsie daisy, I shouldn't have done this. Forgive me, guys. Oh Lord, this is going to take a while. You know, many times it tempted me to do this stuff. Crap. Just hold on a minute, please. Open the document and it came into as a read-only file. So let me just deal with it.
Cause 4, 5, 20. Oh shit.
No, don't read there, son.
Oh.
All right. No, look at it, guys, and tell me if.
Never realized the mic was on.
Okay, no problem. Look at it now, guys, and tell me if this is difficult.
That's the end of the question?
It sure is. It says, find a value of x for which the function is undefined. It implies that x is going to be equal to 4, x equals 5. Because when you put 4 into the function, no, negative 4 into the function, negative 4 squares is going to be 16. 9 times negative 4 is going to be 36. 16 minus 36 is going to be equal to minus 20. Minus 20 plus 20 is equal to 0. So we're going to have 1 over 0. And remember, you can't have a fraction with 0 existing in the denominator. So yes, so these are my answers. X equals 4, x equals negative 4, x equals negative 5. All right. Oh, too small.
Sir, I don't want to wear glasses.
No, what I'm trying to do for you is to put the paper, question on a paper, on a sheet, so that my working out is still projected while you are doing the work for me. So let me just see how I can do this now. All right, got that a little bigger. Try one more time. All right, can you see that now?
Yes, sir.
All right, I'm giving it 10 minutes.
Sir, I can't see it.
All right, you know what? Better for you now, Marie?
Yes, sir, I can see. Question 2, right, sir?
Question 2 and 3, yeah. I'm just going to put some further explanation there. So 5x plus 4x.
Not seeing the question, no, sir.
Oh, hold on, please. I'm trying to make this thing a little easier for you to refresh your memories. All right. All right. Give me more work. Give me a minute. I'm going to step away for a minute.
X squared plus 15 plus 6. That's 7, 7, 8.
Sorry, I can't scroll up a bit.
X
Maria, microphone on, yeah?
Nice, sir.
Sir, can you scroll up so I can see the question for example 1?
Where are we okay?
Well, sir, can you put up question 4? I'm not seeing it.
Right, no problem. I'll put up 4 and 5. somehow I just get the feeling that some of you are there and you are not doing any work. I'm just waiting for teacher to come. This is an exercise for you to get involved. I'm going to be doing only 2 of them, and then we're moving on. Let me just. Of course, the teacher is being lazy again, so. All right, so I need 2 numbers. Okay, so before I go there, I'm going to say I'm multiplying the coefficient of x squared by the constant. 1 times 66 is 56. I need 2 numbers. When multiplied together will give me 56, but when added will give me 50. What 2 numbers are you thinking of there?
7 and 8.
7 and 8, very good. So I'm going to call this 7x, and then I'm going to call this 8x plus 56 is equals to 0. And then I'm going to be grouping to give me 7x, 8x plus 56, 7x. So either x plus 7 is equal to 0, or x plus 8 is equal to 0. So x is equal to -7, or x is going to be equal to -8. And that's what I get from my answer. Is there anybody who agrees with me?
Yes, sir. -8 and.
Yes, sir. That's what I got.
Yes,
What is good?
Chris, what are you saying? Maybe I'll grumble something on this. I want
At least we get 1 right.
yeah, man, you can get all of them right. Okay, so that's example 2. I want to copy and paste so that I can speed up what it is that I'm, oh crap, undo. So that I can speed up my calculation. It's kind of difficult to teach and type, but it is so much nicer when I can finish all of this and I still can send off to you guys. I need 2 numbers and multiply together will give me -6, but when added will give me a +5. What numbers are we talking about?
-1 and -5.
Yeah, use that.
1 and
I don't think so. I don't think so.
I don't think so either, sir.
-1 and 6.
1 and minus.
-1 and what, Chris?
6, sir. Sorry. Wait.
-1 and.
A -6.
And not even that me use either.
Wait, sir. I get 1. -1 plus minus. No, star, I got the 1 there.
-1 and 6.
-1 and 6 is correct.
Yeah.
-1 plus 6. Yes, how am I do this? How am I do this, sir?
Now remember, a teachable moment comes here now. You notice, where's my spotlight? I need my spotlight. You notice when I read right here, so the sign changes to a positive. Whatever sign that is in this bracket has to be the same sign that is in this bracket. I'm factoring out a negative sign.
Sir. Sir?
Go ahead.
I use
-3 and -2.
Yeah.
You can't use it because when you add those, you can get -5. That's why I put that question there because I know trick somebody. When I add -3 to -2, I'm going to get -5. I don't want a -5. And when I multiply -3 by -2, I'm going to get a +6. What I want is a -6. So I deliberately wrote that question because I know students always make mistakes with that question.
I did that, but I think somewhere down the line I make a mistake with the sign. Just watch where I do.
All right. So this is going to be x plus 6. Oh. Let me put another line in betwixt here. Some factor note, what is common between this x squared and the 6x is going to be x. What is left is x plus 6. And if you distribute this x over this parenthesis here, you'll get x times x is x squared, and x times 6 is going to be equal to 6x. What is common between x and 6 is going to be 1. 1 times x is x, and 1 times 6 is 6. And what is common here is going to be the x plus 6. And then we're going to say either x plus 6 is equal to 0 or x minus 1 is equal to 0, which implies x is equal to -6 or x is equal to +1. Those are the answers. Let me just do something here before I forget it.
We get positives. We get -6.
Marie, you're silent.
Oh, sir, good night. I got that, sir. It's not too bad.
Got you good.
It is not too bad, sir. I got this one. I got this one, sir. But me can confess something, sir.
Yeah.
Me put close.
All right, no problem. It's work in progress.
All right, sir.
Work in progress. Emilio.
Yes, sir. Me catch on. So 100, but me I catch on.
All right.
Yeah, man, I go and watch and see what I go on. If anything, me try work out something for myself as usual, and me not get nothing me making.
All right. Yana, how you feel? Jenna, how you feel?
I got this, sir. I got this one. I actually did 4 of the questions.
I'm so proud of you. Oh my goodness. Keep it up, punches. Very nice, very nice. And I hear from JD. Joan.
Yes, sir.
How you feel?
Good man.
You good?
Yes, sir.
Nice. Miss Marlene.
Sir, I'm here. I get this one, sir.
Nice.
I get this one.
Good, good. Feely.
Yes, sir.
How you feel?
So I get in there.
All right. Nice.
Just need
Ricky.
a little more practice.
And just get the practice. You have the questions here. I'm going to send questions to you guys, but it's just what I send, and even looking at the things on edit. I don't even want to go there because anyhow, you guys.
Sir,
Yes, please.
if you are educated, sir, First and foremost, sir, although this is a repetition, but sir, you say if we just continue the maths course last semester, would have a better idea. Yes, it's so some of us spread a math, sir. You see, from we done, we just come like we just put on the books and everything. So everything kind of blaze out. So, sir, I'm stuck on one maths from the other day, sir. I'm decided my mind, so I don't want to pass it. I just want to get a better understanding of it so that I can understand and go on, sir. But it's not that I don't want to do the thing, sir.
Is it the same question that you sent to me in the WhatsApp group? Because
yes,
I respond to you. I respond to you and you don't even open it yet.
Yes, sir. I understand that you respond to me, sir. You said I must factorize it, right, sir? But I'm still not.
So Marie, if I tell you to do something and you're still not getting it, link me again, no man. I say, boy, sir, you know, say tell me to do X, Y, Z. I'm try to now work out. Don't sit down there in oblivion. Yeah, man. Ricky, or you stay.
I'm following, sir. I need to practice with this. As all of them. How I learn it is always when I practice and I do a few of the questions. I know it now, but I just need some practice.
Okay. Romain.
Yes, sir.
Who is still?
Getting there, sir.
All right. Bogle. I'm speaking to her.
Yes, sir, I have a problem, sir.
She have me up. Should we tell us why you have your national?
Yes, sir, I have a problem.
What problem?
Sir, I realized, right, when I multiply the constants with the coefficients, right, and to get the middle number, I find out I pay more attention to getting the middle number, and then when multiply those two, in not getting for example, sir, where you have, because I had a -1 and -5, because when those two are added, right, I'm going to get -5, -1 and 5, I'm going to get
-6.
-6.
Sir, wrong example.
Okay then.
Sir, example 4, you did that one?
No, I didn't.
Sir, I have 6 and -6 and -1. When I had 6 and -1, you're going to get the. Sir, I don't even know up here. Let me not explain this good. Not translate.
What are your factors? Jesus.
Sir, I have 6 and -1. Which cannot
What?
be. Yeah, right. It cannot be.
No, because you know what it is that you want to know is two numbers. When multiplied together, we get a +6. But when added, we get a -5. Hold on there.
Right, sir. So I'm paying more attention to the middle number, because when I have -6 plus 5, I'm getting the -5. But when I multiply it, it's not. It's not.
So it has to fit both conditions. Okay. You remember your answer you gave me for the first one?
And that we have again.
All right. At that one, the answer you know, -3 and -2.
Yes. That's what I have.
Yeah, man, a -3 and -2.
All right. Sir, I think the last step that we usually did, at least what I remember, where you sit down at the bottom before you write this implies, where you have either x plus 6 is equal to 0. What they're saying is that it's x plus 6, but when you want to know what x is equal to, you have to put down x where the 0 is. X is equal to 0. I think how you put it now, your minus something, the signs would change because you're trying to get the equal sign. You need the x on the equal sign on the other side. So if you have the +6, it would be -6, and if you have the -1, it would be 1.
Yeah, but that's not where Shanake is doing. Shanake is saying that she when she multiplies the coefficient of x squared by the constant and she gets +6, She's focusing only on one of them and not both. So she's getting a -5, but she's not getting the +6. Or she's getting the +6 but not getting it. So she is stuck right there.
Okay.
Right. So it's just for her now to recognize that I need two numbers. When multiplied together will give me the product, but when added will give me the middle number.
Right.
COEFFI. All right. Read that and see if that makes any sense to you. I'm trying to read that and see if that makes anything clearer for you. I don't know. I'm just trying something here.
Sir, I get the concept, thank you.
You're welcome. Pay me later.
Okay.
All right, so I'm going to leave that there for those of multiply the coefficient of x squared by the constant term, and only two numbers when multiplied together gives that product, but when added gives the middle number. Okay, yeah. All right. Let me just finish this question since I started it.
I wonder how the factorization looks a while ago. I wonder myself.
No, I didn't finish it because that's tough. And then that is going to be -2 into x minus 3. And then I'm going to have x minus 2 times x minus 3. And then add x minus 2 is equal to 0, or x minus 3 is equal to 0, which implies x is equal to 2, and it also implies x is equal to 3. And that ends that question. All right?
So if you have it the other way around, right?
Same difference. If you have x equals 3 first, right, and x equals 2, same difference. Tomato, tomato.
Okay.
All right. So you have just one question for those of you who didn't finish the question, to go ahead and finish it. I won't do that question.
Yeah,
because
4.
Huh?
So you're moving from 4?
You want to look at it a little longer?
Yes, sir.
All right, no problem. For those of you who may be joining class for the first time, I really hope I don't have enough view. But remember, it's now 9 o'clock. We're going to work up until 10 here. Yes, Father God. Thank you.
10 o'clock. Subscribe.
You can move it here. Thanks.
Okay, so I've looked at continuity, and now I want to look at some average rate of change. And this is the last topic in our unit 1 to 3. So we're now going to be moving on to unit 4 after this, right? This is our last topic in our unit 1 to 3, average rate of change. I don't call it ARC. Well, I call it ARC. I call it ARC because it is average rate of change, right? Now, I'm just going to teach you this topic by just giving an example and then show you how practical the question is. I'm just going to teach you this topic by using an example. And incidentally, guys, I'm finishing this document tonight. If I can't start unit 4 tonight, that's fine. But I'm finishing out this tonight, and I don't need much time. And to be honest with you, within half an hour, I can finish off this and then just use the other half an hour to just introduce something to you in preparation for Thursday's class, all being well. So let's just look at the average rate of change. Average rate of change. You know, where does this become important? Say you have a business and COVID, you know, one of the things that amazes me in COVID here is how these merchants have just inched up the prices of goods and services. And because you want the product, you go buy it. I got Tasties the other day and they know it's a Patigano. Me got Burger King the other day and I said, why the prices here look so different? It's a Rockstone. We got supermarket, and one little something gone like about 2 times the price, like my father friend. And if the price remains the same, when you look at it, you get far less in the container. Case in point. I was snacking last night even, and I decided to snack on a cheese curls. And the bag feel puffy and nice, you know. I say, you know what? I'm going to choke the contents in one plate. I'm going to count how many cheese curls or something, pure ear.
Yes, sir.
By the time I do some, it's done. And I'm saying to myself, my God. Now, where am I going with this? You can actually calculate the average rate of change of the price of an item before COVID and during COVID. You can calculate the average rate of change of the price. So this is where we are now. This is where we are, the average rate of change. I'm going to just give you some layman example and then give you one practical example of it to show you how we can go about doing the calculation. So it says determine the value of x. I want you to determine the value of x for which g of x is undefined. But sir, we not just did that a while ago? Absolutely. So you see what I just gave you a while ago is what it is that I'm asking you to do now. And I'm going to ask each of you to write that function of g of x for me and give me the value of x that makes it undefined. On your mark, get set, go. Start and then tell me.
So, sir, when you undefined, the denominator be 0. Is that the answer, that one?
Yes, please.
So 2x over 0.
Give me the value of x that makes a function undefined, please.
0.
No.
3, sir. This one? No. Can't be 3.
For 1 mark students, I'm waiting for the answer.
One, sir.
You guys are joking. We're not ready for this yet. We're not ready for this yet.
I'll check again, sir.
No, it's not 2.
A 0. Me get 0 now. I don't know why.
Sir, is it 2/3?
No.
Sir, we're not going well. Look like you have to deal with it.
No, me not deal with it, sir. Me not deal with it. I just finished that topic with you a while ago.
Two over three?
No.
Sir, is the 2/3 is minus 2/3?
Thank you. Everybody see why it's negative 2/3?
It look like I'm well lost, sir.
Oh.
It's like
If I say to you that when you get a rational function, the denominator cannot be equal to 0. So you are going to let it be equal to 0 so you can find the value or values of x or whatever variable they give you to see what value or values will make the denominator equal to 0. Those are the values that you want to isolate. So all you have to do is to set the denominator equals to 0. So you're going to have 2 plus 3x equals 0. 2 plus 3x equals 0, and you're going to find the values of x, or the value of x in this case.
Okay. Oh, when you carry it over to the, oh, yes.
So I did that, but I was trying to find multiple values. I don't know.
It's a linear function. Linear functions give one. I'm sure all of you did foundation 3 now. I didn't teach you foundation 3. But in
No,
foundation
I
tree,
did. I don't do foundation trees.
well, you'd have done it in CXE math. I used to teach
Very
CXE
true.
math. And I'm saying to you, when you have a linear function, you have the highest value in the function raised to 1. And when you solve that linear function, if you're given a linear equation, you have only one answer. Linear, one answer. That's straight line. If you have a quadratic, it gives you the number of solutions will be 2 because the highest power in the quadratic is 2. If you are given a cubic,
I'm in business.
Mute Christopher, I don't want to hear I love you, right? If you're given a cubic function, the highest value is going to be 3. So the highest value, the order of the polynomial gives you the number of answers that you're supposed to get. So once you have a linear function, you know it's one answer you're supposed to get. 2 plus 3x equals 0. The highest power in that is raised to 1, so 1 answer you get. X squared plus 7x plus 12. The highest power in there is 2, so 2 answer you're going to get. X squared plus x cubed plus x squared plus x plus 2 equals 0. A 3 answer you're going to get because the highest power in there is 3. Come on now. All right, let's go. So now it is asking us to do the average rate of change of g of x on the interval. The average rate of change now. Now, you are given a function g of x. You know the value of x for which g of x is undefined. They are now asking you to evaluate the average rate of change. To evaluate the average rate of change. Hear me out. Telling a story again. Story time. The average rate of change is going to be equal to f of b minus f of a over b minus a. That's the formula. Average rate of change is going to be equal to f of b minus f of a over b minus a. F of b minus f of a over b minus a. So where them get a from and where them get b from? See it right up here, sir. -1, 2. The bigger value is b, the smaller value is a. The smaller value is written first, the bigger value is written after. Smaller value is written first, the bigger value is written after. So inside of here, sir, let me see if we can write it so that we can see it.
Sir, you said always the bigger number, the bigger value is b?
Yeah.
Okay.
Sir, my internet went a while ago. My light, everything dipped a while ago. I think the people have a trope now tonight. Sir, I didn't get that part. The first one, g of x is equal to 2x divided by or over 2 plus 3x is an undefined. The value of x. Yeah, I missed all of that, sir.
That's funny. That's funny. All right. So if you, I'm going my right. I'm just saying to you, part 1 of what it is that we have there is what we just completed. It says find the value of x for which g of x is undefined. G of x is undefined. G of x is undefined when g of x is undefined when sorry.
When the denominator is equal to 0.
Very good. Very good. Hold on 1 minute, please. 1 minute. Hold on.
So as long as it's equal to 0, we're going to get a negative as an answer, -2/3, because the 2 where the x's are, those are the ones that you recognize, 2/3. I'm trying to understand it, sir.
No, the time is wickedly hot. Jesus, Father. No story. Right. So thanks, Christopher. So it is undefined when the denominator is equal to 0. So all I'm going to be doing is setting the denominator equals to 0. What is that, sir? I'm saying let 2 plus 3x to be equal to 0. 2 plus 3x equals 0. 2 plus 3x equals 0. So that's what I did in part 1. Right here. 2 plus 3x equals 0. So x is going to be equal to negative 2/3 when you do your stuff.
Oh, because now it seems familiar, dear Jesus. We did this already so long time ago. Why it never click?
All right. And then now I'm moving to the average rate of change, and I'm saying in order to do the average rate of change, and what I did, I tried to color code it. So up here, don't ask what color that is, but it's a different color from the one in blue. The formula says f of b minus f of a over b minus b. You need to remember that formula. F of b minus f of a over b minus a. F of b minus f of a over b minus a. F of b minus f of a over b minus a. What you're doing, you're putting the value of, you're substituting the value b, whatever b is, you're substituting that into the function. You're writing down the answer. Then you again substitute the value a, and you know what a is. You are the first one, and you are the second one. And you're substituting the value a into the CX function. Write down the answer there. Then you're going to say b minus a. You write down that one there. And then just substitute it in the formula. Whatsoever f of b is, you write it down. Whatsoever f of a is, you write it down. F of b minus f of a all over b minus a. Voila. Twerk it, twerk it, twerk it. And you'll get your average rate of change. Watch me. My function is g of x is equal to 2x over 2 plus 3x. So you recall that g of x is equal to 2x plus 3x. 2x over 2 plus 3x. Anywhere in the function you see x, substitute 2 to evaluate f of b. Anywhere in the function you see x, you're going to substitute 2. Sir, where the 2 come from? See the 2, yes, sir? The 2 are the b. A comma b, a come first, b come after. B, f of b, the b are the big one. You put in f of b minus f of a. So it's going to be anywhere in the function you see x, you're going to substitute 2. So it's going to be 2 times 2, see here? 2 times 2 over 2 plus 3 times 2. That's what your f of b is. Then you get minus your f of a. F of a is negative 1. Same function, 2 times negative 1 over 2 plus 3 times negative 1. All right? Anyway, the function you see x, substitute negative 1 to evaluate f of a. Same difference. Now, what we're going to say is 2 times 2 is 4. Sorry, it is on, okay, much better. 2 times 2 is 4. 3 times 2 is 6. So it's going to be 2 plus 6 minus negative 1 times 2 is negative 2. And 3 times negative 1 is negative 3. So we have 2 minus 3. And 2 minus 3 is negative 1. And 2 plus 6 is 8. So I'm going to have 4 8s for a. And negative 2 divided by negative 1 is going to be positive 2. So it says subtracting the two functions to find the LCM to give you all of that. All right? Now, 4 over 8 is the same thing as a half. And negative 2 over 2, of course, that's what is going to be positive 1. So all of that is going to be equal to negative 3 halves. When you do all of this, remember a half minus 2 It's going to be negative 3 halves. It's going to be negative 3 halves. Negative 3 over 2. But I'm not done because I need to find b minus a. b minus a was negative 1, b 2, so it's going to be 2 minus minus 1, which is equal to 3. So when I substitute all that now into my formula, remember f of b minus f of a is going to be negative 3 halves. So it's going to be negative 3 halves over 3. Negative 3 halves over 3, and that 3 is the same thing as 3 over 1. I have two fractions separated by rubbishness. I'm dividing two fractions. I'm going to invert and multiply. So it's going to be negative 3 over 2 multiplied by, I'm inverting. Instead of 3 over 1, I'm going to say 1 over 3. The 3's cancel, so I'm going to have negative a half. And that's my answer. Negative a half.
Sorry, you can scroll up so I can write it down.
Not only that, I want to minimize it. Wow, Marie, you cost me to say don't wear glasses, but I hope this can. All right. You can take it out from there. I give you a couple.
I'm sorry.
Let's see how to send this, sir.
I am actually.
Yeah, so then I need to take off now. Send it come.
Oh, wait, when I write
I need to write it. I'm writing it.
It off, Emilia, when you just
zoom in on your phone now. You can zoom in, Janelle. But I'm using a laptop. I'm seeing.
Let me know when you want me to scroll up.
You can scroll up, sir.
Sir, stop. Stop.
Sir, question. Right at 1, right? Should it be half minus 2 over minus 1?
No, man, because when this is negative 2. Look up here. Negative 2 divided by negative 1 is positive 2. Because when I divide two negative numbers, I get a positive number. But there's still a negative sign that is in betwixt, which is a black one. So that this negative sign that is right here, where the spotlight is the same negative sign here. But this negative 2 divided by negative 1 becomes a positive 2 over positive 1.
Okay, thank you.
Come on, guys, I'm actually waiting for you now. I need to move.
I am through, sir.
Thank you.
Same.
The rest how we are waiting for the people. Senate. You could have moved long time.
All right. All right, let's go.
You can go ahead.
All right. Let's just look at this practical example. All right. So you know what? Before I do the practical example, go through that example for me, please.
Sir.
This one.
There's a yellow thing over the thing. Is there's a and there, sir.
One more. I hope because I'm not gonna speak on me, you know, and that you're working on the question. Anybody finish the first part?
Is it -6 and 1?
Do you recognize that I gave you that function already in one of the questions? That function x squared plus 5x minus 6.
Yes, sir, you did. That's what I went back and look at. No, this is -5 and this one is +5. So it's the second one. I think it's question 3.
X squared plus 5x minus 6. Yeah, so it's going to be -6 and 1. Yeah, so it becomes -6 and 1. Yeah. So you recognize that the numerator really doesn't make a big difference to what it's supposed to be. All right, so now that you see, so you recognize that the question on this on continuity comes with the average rate of change. So that's the idea of having those done up. So all right, so we're gonna get -6 and 1. Now we need to the function is going to be between 0 and 3. I'm evaluating in this case 0 and 3. I'm evaluating in 3. Anyway, in the function h of 3 is going to be 7 times 3 squared plus minus 8. And I'm substituting 3 into everything in the denominator. So it becomes 3 squared plus 5 times 3 minus 6. 3 squared is 9. 9 times 7 is 63. 63 minus 8 is going to be 55. And 3 squared is 9. 9 plus 15 is 24. Minus 6 is 18. So I'm going to have 55 over 18 for that one. All I'm doing is substituting. So the average rate of change is really a substitution. All I'm doing is substituting. Nothing more than substitution. Then I'm going to evaluate f of a. And f of a is going to be equal to 0. So anywhere in the function I see x at 0. So all of the x values then become 0. That's the constant terms that I have left, which is -8 over -6, which is going to be 4/3. And then f of b minus a is going to be 3 minus 0 is equal to 3. And then I substitute it into the formula. So I'm going to have 55 over 18 minus 8 over 6. And that gives me, wow, 31 over 18, and then divide that by 3. It looks untidy here, but I was just trying to show you what the calculation is. So it's really 55 over 18 minus 8 over 6, and that gives me 55 minus 24 over 18, which is really 31 over 18. So let me just put this equals 31. So that is equal to 31 over 18. And then it's f of b minus f of a all over b minus a. So I'm now going to be substituting, sorry, dividing it by 3. And do it by 3. Then I divide 2 fractions, really 3 over 1. I'm going to invert, I'm going to get 1/3. So it now becomes 31 over 54, which is 0.57. Are there any questions with that?
Sir, go back up, please. The question gave us the interval, right?
Yeah.
Go back up. Come here, see where we get you from. Oh, never mind. See then.
Let's carry it on.
So can you just carry it back down a bit? Let me screenshot the first part, the solution one at the top. Okay, hold on, let me. Okay, so you can.
Are we okay now? Hello, 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 hello.
I am good, sir.
All right. All right.
Is you writing? I'm still writing.
Okay, right. And when we finish writing, we end it here for tonight. We'll pick up the other question from tomorrow. I mean, Thursday.
I can hardly hear what you said a while ago.
I'm just saying to you that when you finish writing, this will be it. and we'll pick up the other question on Thursday.
Okay,
So I can go ahead and, you want me to just go ahead and send this in the group?
Yes, sir.
Sorry, if you send it, me not write it, you know. Yeah, tell me the honest truth. Can you give me a few minutes, please?
All right, no problem, honey. But I'll send it in the group on the list.
Appreciated. Thank you.
Bless your heart. See her? Take care, guys.